yesterday I showed you how to solve something like this, correct? Your step was number one, you get the radical alone, right? And then you raise it to a power that matches the index. Yes?
Yes.
Okay. And then you would go ahead and check whenever the index was what? Even, right? Which for our cases, we're mostly sticking with 2s and 3s, maybe a 4 here and there. So the 2s and the 4s, you're going to have to check. The 3s, you don't have to, as long as you're confident you did the work correctly. Now, I'm going to say something to you, and I want you to look at it for a minute. This example right here is exactly the same problem as that one.
Yeah.
Do you see that?
Yeah.
It's exactly the same problem. So how would I solve this one? So what would I do to solve this one? If it's the same problem as that one, what am I going to do? I'm going to raise both sides to what power? Now, the reason why I raise it to the second power is that the power that I need to raise it to is actually the reciprocal of the exponent. And with an exponent of 1/2, 2 happens to be the reciprocal. What is 2 times 1/2?
1.
So that means I have x to the first equals 25, which is x equals 25, right?
Yes.
Do I need to check it? Well, it technically was already checked for me over here, right? But if it hadn't been checked for me already, would I need to check this? How can I tell if the index is even? When you have an exponent that's a fraction, what part of that fraction is the index? The denominator. So now, when we have it written this way, anytime that denominator is even, you have an even index and you need to check it. If the denominator is odd, you do not need to check it as long as you're confident that you did the process correctly. Okay? The rest of it is still the same. So the first thing you're going to do is you're going to get the variable that has, or whatever it is that has the fractional exponent by itself, and then you're going to raise both sides to a power, and the power you're going to choose is the reciprocal of whatever fraction it is. So if I look at this guy right here, is the variable with the exponent by itself? Yes? No? Anybody? Bueller? Bueller? Is the variable with the exponent by itself? No, there's a big old 7 in front of it. Do you see that?
Yes.
How can I get rid of that 7? Divide by 7. That leaves me with x to the 3/5 equals, what is 56 divided by 7? 8. Now, as I'm looking here, is my index even or odd? What is my index? 5. So am I going to need to check my answer? No, only when my index is even. Okay? What am I going to raise both sides to? Not the 5th power, the reciprocal power. What is the reciprocal of 3/5? 5/3. So let's look at what happens here. What is 3/5 times 5/3? 1. So I have x to the first power, which just looks like that. Right? And then over here, I have 8 to the 5/3, right? Now I could either go to my calculator, or I could recognize that that's the cube root of 8 raised to the 5th power, right? If I were to change it to radical form. So what's the cube root of 8?
2.
2. What's 2 to the 5th?
4, 8, 16, 32.
32. Can I check that on my calculator if I want to? 8 to the 5/3 power is 32. And I don't need to check it because I had that odd index. So? It's basically the same as yesterday, just a little different. All right, this time it's not just a variable that has the exponent. It's this parentheses. So I have to get that parentheses by itself. So what do I need to move first? The 1, because I got to get that parentheses by itself. So that leaves me with x plus 2 to the 3/4 power equals what? 8. Now that I have my exponent term by itself, what am I going to do? Raise both sides to the what power? 4/3. Why do I not just raise it to the 4th power? Or why did I not just raise it to the 5th power over here?
Because it's not over 1.
Because if I raised this to the 5th power, I would still have x cubed. Do you see why? Because 3/5 times 5 would just be 3. I would still have x cubed. That's not getting x by itself. That's just changing the exponent that's there. I want to get that exponent to 1, so I have to use the reciprocal. So what is 3/4 times 4/3? So that leaves me with just x plus 2. And what's 8 to the 4/3? Well, we just did 8 to the 5/3, didn't we?
16.
So it's going to be 16? Because the cube root of 8 is 2 raised to the 4th power is 16. Now I'm going to subtract 2, and I get x equals 14. Do I need to check my answer?
Yes.
Why? That denominator is even, which means the index is even. I'm going to check it on my calculator. Parentheses, 14 plus 2 to the what power? 3/4. Now, just because I don't know how my calculator is going to feel if I put the -1 right now, I'm going to click enter. Then I'll do my -1, and it does give me 7, so my answer checks out. Questions about that one? Yes? No? All right.
Can you just look at that real quick?
Uh-huh. The last one at the bottom, am I going to need to check my answer?
No.
I think you sorry.
That denominator is a 3, which is odd. So I'm not going to need to check my answer as long as I'm confident with how I'm doing my work. So, is one of my, by the way, this type of problem right here is exactly like this guy, right? So I need to make sure that at least one of my exponent things is by itself, which this one is. So I can go ahead and raise both sides to the what power?
3/2.
3/2. So what's 2/3 times 3/2?
1.
So that's going to give me 3x plus 1 over here. Now on this side, what was it that I told you we have to be careful to remember?
You have to do the outside number too.
It has to apply to both the 4 and the parentheses. And how it applies to the parentheses is by applying to the exponent on the parentheses. So that gives me 4 to the 3/2 times x plus 2. And the x plus 2 is where the exponent cancels out there. What is 4 to the 3/2? 8. How'd you get that so fast?
Because I did.
Square root of 4
2.
cubed is 8. So I have 8 times x plus 2 equals 3x plus 1. Easy from here on out. 8x plus 16 equals 3x plus 1. I'm going to move the 3x. That gives me 5x plus 16 equals 1. Subtract 16. 5x equals negative 15. Divide by 5. And x equals negative 3. Do I need to check my answer?
No.
Can I check my answer if I want to?
Yes.
Yes, I am going to check my answer here just because I want to make sure that you guys understand the checking process for something like this, okay? So even though I don't have to, I'm going to check it. So if I got x equals negative 3, I need to see, does 4 times negative 3 plus 2 to the 2/3 power equal the same thing as 3 times negative 3 plus 1 to the 2/3 power. So in other words, I'm basically looking at this as two different things to simplify, and as long as they simplify to the same thing, my answer's good. So let's see, this would be 4, and then negative 3 plus 2 is negative 1. What's the cube root of negative 1?
1. Negative.
Negative 1 squared?
1.
1. So this is really 4 times 1, and I could check that on my calculator if I wanted. Negative 1 to the 2/3 power. Ah, it's freaking out on me. Oh, it doesn't want, oh, okay. It doesn't want to do it in exponent form. It only wants to do it in this form. Squared. It only wants to do it in radical form, so it will do it in radical form for me. So it does equal 1, and 4 times 1 is 4. So I just got to see if this side ends up equaling 4 also. So let's see. 3 times negative 3 is negative 9 plus 1 to the 2/3. Negative 9 plus 1 is negative 8 to the 2/3. And negative 8, it's not going to like it, is it? To the 2/3. Nope, it doesn't like doing exponents like that. So I have to plug this into my calculator in radical form. So I'm going to plug it in as the cube root of negative 8 squared, which I happen to know is negative 2 squared, which is 4. It will check out. But if I plug it in this way, my calculator doesn't freak out for some reason. There's my negative 2 squared is 4. So does my answer check out? Yes. So sometimes you may come across times where your calculator just doesn't like the idea of any negative number under any radical, or I should say with an exponent that's a radical, that's a fraction, meaning it is a radical. So just change the form to radical form, and your calculator should be fine with it then. Okay? Some calculators are okay with it either way, but yeah. All right? Happy studying.